Okay, so now we're going to look at volumes of pyramids and cones, and we're going to skip over these investigations since I'm not here with you today. And the volume of a pyramid, the formula is the same as it was for a prism. The only difference is it's now 1/3 of that. So a prism was just base times height, area of the base times height, that is, and this is 1/3 of that, 1/3 base times height. So let's look at the volume formula for a cone. So cone, same thing. This was the formula for a cylinder, and a cone just happens to be 1/3 of the volume of a cylinder. And you should note that this applies to both right and oblique pyramids and cones. So it doesn't matter. The volume will be the same regardless of if it's slanty or straight. Okay, so let's look at our first example. Okay, so my formula is 1/3 area of the base times height. And my area of the base, that's pretty not too bad. That's 1/3 times 9.2 times 9.2. But I don't know my height. My height is going to be this guy going right up the center, and I don't know it. So I have to figure out some way to come up with that height. And the strategy for that is to draw a segment completing this segment here, which we're going to learn later is called the slant height, that 13. The altitude of one of those side triangles, one of those lateral sides. And if I go from the height, the altitude going up the middle of this pyramid and connect to that other altitude, I've conveniently made a right triangle, in which case the base of that triangle is half of the 9.2. It's 4.6. And now I can just do the Pythagorean theorem to find the height. So go over here in my side work, a squared plus b squared equals c squared. So 4.6 squared plus h squared equals 13 squared. 4.6 squared gives us 21.16. And then subtract 21.16 from both sides. And that gives us 147.84. And then if we take the square root of that, your height is approximately 12.15. So back to the original problem, we're finding the height to be that 12.15 number times 1/3 of 9.2 times 9.2. And that comes out to be 343.0 yards cubed. So what I am going to ask you to do is pause the video and try this same strategy on the U-Try, and then we'll come back and check and see how we did. Okay, so I've drawn in my height, that red segment there going up the middle. We know that the base of that right triangle that I've created is 5. And so now if I want to find my height, right, this is what, a 5, 12, 13, that's a triple, or you can do the Pythagorean theorem and you'll get 12 either way. So that's my height here, and we already knew that the base was going to be, area of the base was going to be 10 times 10 or 100, and then so that comes out 1/3 of 10 times 10 times 12 is 400 inches cubed. All right, let's take a look at example 3. Find the volume of each cone to the nearest whole number, our instructions. So we're talking about 1/3 pi r squared h, right? So that's 1/3 pi, we know our radius would be 5 if our diameter is 10, squared times, oh, again, we don't know the height. And so this time, let's look at what we have. We have this right triangle with the 25 degrees in the top corner. So on this situation, we can do what? Opposite and adjacent to find the height. And so that would be, we're going to go over here to our side work. We're going to do tangent of 25 degrees equals opposite, which is what, 5, over adjacent, which is our height. Tan 25 degrees comes out to 0.466. So when I cross multiply, I get 5 equals 0.466H, or divide both sides by 0.466. And we get 10.7 for the height, approximately. 10.72. So that is our height. Then we just plug that into the formula. So we've got 1/3 times pi times 5 squared times 10.72. And I'm actually using all the decimals in my calculator for that. And we get 280.7. So to the nearest whole number, that's going to be 281 inches cubed. Okay, I'm going to turn you loose and let you try. So pause the video and then we'll see how we did.